Okay, so we are starting Unit 4, which is graphing, anything to do with quadratic functions, solving them, graphing them, all of it. So, quadratic functions are functions which show two solutions usually. Once in a while there will be one. And they may be real or imaginary. We'll talk about imaginary solutions later. And they have two changes of direction when we look at the graph. Yes? You're always responsible for it, so it may be on the test. You need to be writing all of it down. Okay, so the standard form for a quadratic function is actually up here at the top, which is y equals ax squared plus bx plus c. Does anybody know what those a, b, and c variables stand for? What do they represent? They just represent coefficients, just numbers. Yep, Rose, is that what you were going to say? So a, b, and c are coefficients. Okay. Who can give me a good definition of a parabola? Or tell me what they look like? Rose. They go up and then they go down. What could they also do? They can do that too. Jacob. They arc. They definitely have an arc. If they can go up and then go down, is there a time where they could go down and then go up? Yes. Okay. So they can do that also. Okay. So it's a U-shaped graph. And it has a maximum or a minimum point. We'll get to that in a minute. Okay. So the parent function just looks like y equals x squared. Okay. That means all of my a, b, and c values, my a value is 1, b and c are 0. Okay? You're going to learn a lot about parent functions this year, because then when you come back to Algebra 2 and you're doing much more complicated functions, they all act the same way, behave the same way, change the same way. They're all exactly the same. Okay? Does anybody know what that maximum or minimum point is called by chance? Rose? Go ahead. Be brave. Starts with a V. Sounds like Tertex. Vertex, there you go. Okay, the vertex is the point where a parabola changes direction. It is also the maximum or minimum point. Okay. So today we're going to do a lot on the vertex and the axis of symmetry, because that helps you a lot in dealing with parabolas and quadratic functions. A lot. If you can find that middle point, finding the rest of it and being able to graph the rest of it is piece of cake. That point is really important. Okay. Does anybody happen to know what the axis of symmetry might be? What does symmetry mean? It's, yeah. Rose. What is something symmetrical? What does that mean? That's a really good word. It mirrors each other, right? So an axis of symmetry is kind of an imaginary line. And when we draw it on our graph, we draw it with a dashed line. And it's just right down the middle of the parabola. And if it's right going through the middle, what point would it also go through? The maximum, which is called the vertex. Good. Through the vertex. One side mirrors the other. That's a really good description of that. So when things are symmetrical, it means that if you split it right down the middle, this side would look like this side. So if I took a basketball and I sliced it right down the middle and the air did not go out of it, one side would look exactly like the other side, right? If I took an ice cream cone and it was had a cone and has a perfectly round sphere of ice cream on top, and I split it right down the middle, I should have two identical halves if they are symmetrical. Okay? Make sense? If I cut an M&M right down the middle, either direction, whether I did it horizontally or vertically, either half should look exactly the same if they're symmetrical. Okay? That's what that means. What? That's true. I mean the actual chocolate part of the M&M. There's a cool thing they showed on how M&Ms are made. One of my kids did a project on it in elementary school. Did you know that all M&Ms are actually white underneath the whatever color they are? That's actually the thickest part of that coating is the white part, which I never knew until I think Mark did his project on that. So. No, then they dip it in the color. But they dip it in white first to cover the chocolate that's on the inside. A little fun fact in case you get on Jeopardy someday. Okay. So let's go down to graphing the parent function. So what was the parent function again? Somebody give it to me from up above. To the second power. So for now, we're going to make a little table of values. You will get to the point very quickly where you will not have to do this. That's the point I want to get you to. Winter's very excited about that. Okay, so what's an easy number to pick? 0. I love 0. 0 makes calculations very easy. Now don't be confused, but I'm going to put it right in the middle, and you'll see why in a minute. Okay? And then I'm going to go one above and one below, and then 2 above and 2 below. So what's 1 above 0? What's 1 below 0? What's 2 above 0? What's 2 below 0? -2. Okay, now let's start with that 0, and I'm going to plug in my x values up here. What's 0 squared? 0. What is 1 squared? What is negative? What? Oh, we got a debate going on. What does 1 squared mean? 1 times itself 2 times, right? So 1 times 1 is 1. What's -1 squared? 1 also. Whenever you square something, is your answer always going to be positive or negative? Positive always. Okay? Until you get to imaginary numbers. Then all bets are off. Wait a minute, imaginary numbers? God, we have enough problems with regular numbers, Miss V. Don't start making them up. They're actually not that bad. Okay, what is 2 squared? 4. And what is -2 squared? 4. Well, that's weird. How can I get the same answer out when I put different answers in? Is that okay? That is okay, right? Because 2 people on the same soccer team can score the same number of goals in a game, right? But the reverse is not okay. I can't have the same person score 4 goals in a game and 2 goals in a game. They did one or the other. So this is okay. This is the function. Okay, so I want you to go over to the graph now, and I want you to graph those points for me. I would like you to label the vertex and see if you can figure out what the axis of symmetry would be. Gauge. Oh, hang on. Hang on. Get a graph first. Najee. I don't know. Tell me where to graph first. Okay. Good. 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 Yep. Good. And I should have that little U shape, right? Good. Okay, what point there is your vertex? 0, 0. How do you know that? It's the lowest point. So does this graph have a minimum or a maximum? A minimum. You cannot go any lower than 0, than x equals 0. Okay? So this has a minimum. Does this look like the things we were graphing before? Oh, that's weird. Why do you think not? Well, our other ones were curved. This one's curved. What's the only difference? This one is a right shape, right side up U. What were the other ones? They were they right side up or upside down? They were upside down. Okay, we'll come back to that in a minute. Okay, does anybody gauge? Did you say something about the axis of symmetry? It would be at 0. So I want you to, when we do an axis of symmetry or an asymptote, when you get into those two, you do those with a dashed line. So the axis of symmetry is going to be at x equals 0. And the axis of symmetry, this is why it's important. If you know where the middle of that parabola is, then it's a lot easier to graph, because then you can find the vertex. Once you find that, the rest is easy after that. Finding that vertex and that axis of symmetry is really important, okay? So the axis of symmetry actually has its own little formula, and it's really easy. Symmetry, which is negative b over 2a. Okay? So I want you to look at that parent function, okay? So we have y equals x squared. What happened to my b and my c in this case? How many x's do I have? 0. I don't have any, right? And I don't have a constant. So what are my a, b, and c values? What's my a value? There's nothing in front of it. What is it? 1. So a equals 1. What does b equal? Here, let me help you with this. That's the standard form, right? So what's b equal? 0. And what does c equal? 0. So now can we plug those numbers in over here pretty easily? Okay. So what's the opposite of b? Negative. What's the opposite of our b value? Negative 0, or just 0. And 2 times, what's 2 times 1? 2. What's 0 divided by anything? 0. So that's my axis of symmetry, which is what I set up here. The cool thing is it also becomes the x part of that vertex. That's how you know what number to plug in to find that vertex. That number is really important. Okay? Really, really important. All right. Does everybody have that page or no? Shane, you okay? Okay. So I'm going to actually, on mine, you don't have to do this. I'm going to draw in my parent function on the 4 of these. You can do this if you want. but I'm going to draw my parent function just so I can see how things change when we graph them. So this, my parent function, is going to be in purple. Okay, on all of these. But it'll help you kind of see what's going to go on. So it's pretty quick for you guys to graph in if you want to. You don't have to, but it might be helpful. Okay, so let's see. Oh, let's pick random helpful volunteers, shall we? Your favorite thing ever right now. Hang on, Rose, because you have volunteered all day today and you're doing awesome. Melanie, number 2. So let's see if we can find that axis of symmetry first, because that's going to tell me where my middle's at. Okay, so do I have, and what are my values for A, B, and C? What's A equal? Here's my A, here's my B, here's my C. So what's A equal? It's that number that goes in front of the x squared. Does everybody understand that? So ax squared plus bx plus c. Remember, these are all just numbers. It's just that number. There's no calculating. There's no nothing. Just tell me what you see. Okay? So 1/2 is my A. What's my B? 0. And what's my C? So here's the kicker. When you don't have a B and a C, your middle is always going to be at 0. We haven't moved it anywhere yet. It's always going to be there at 0. So when you use numbers to plug in, make the 0 your middle one all the time. Now let's just plug in. So what's 0 squared? Times 1/2. Still 0, right? So far we're on the same point. Now pick 2 above and 2 below your middle. Why am I doing 2 above and 2 below? Here's my middle. Everybody look up here to me. Here's my middle. Then I'm going 1 out and seeing where it goes, and going 2 out and seeing where it goes. Because it's got to be a U shape, right? So like picking 5 over that way doesn't really help me. Let's just go 1 out and then 2 out. Okay, so what's 1 and 2 above 0? Wait, hang on. What's 1 above 0? 1. And what's 2 above 0? 2. What's 1 below? Now say negative. There we go. And negative 2. Okay? As long as your middle is 0, those are the numbers I would pick to graph. Okay? Okay, so, Melanie, you ready? You ready? So we're plugging into y equals 1/2 x squared. Right? I'm just going to write it a little bit bigger because that's a little bit small. So what is 1 squared? Times 1/2. That'd be 1/2. Good. What is 2 squared? And what's 1/2 of 4? 2. Good. What is negative 1 squared? Times 1/2. And what is negative 2 squared? 4 times 1/2. 2. What do you notice about when I scooched out 1 above and 1 below? What did you notice about my output? Was it the same or different? Same, right? I got 1/2 each time. What about when I scooched out 2 in either direction? Same, right? Your output in a parabola should be matching pairs of outputs all the way up or all the way down. So if you're getting 1 and then you get some really weird number the other direction, check your negatives, check your signs. That's usually the issue. Okay, so let's graph that. So negative 2, 2, negative 1, 1/2, 0, 0 is okay, 1/2, and 2, 2. So now there's my parabola. What did it do from the parent function? How did it transform it? You're going to hear me use that word a lot. How did it transform my graph? Give me a description for the black one compared to the purple one. It made it smaller? What? I heard something back there. Wider? made it flatter, right? Okay, there's a word that we use called compress. It compressed it. Think about if I've got a tennis ball. Here, what's your tennis ball? Right? And I'm going to use my superhuman strength and squash it, right? Can't do that with a tennis ball, right? It's going to make it flatten out, okay, if you compress the tennis ball. Okay, have you ever seen slow motion? They'll do it when they have tennis matches, and they'll show it in super slow motion when they hit it, and it actually does compress, right? It's pretty cool, actually, all the slow motion stuff. And the ball will actually compress. It'll get flat on one side when they hit it, okay? Sheet everything. Yeah, I love slow motion stuff. Okay, so the deal is when this A is less than 1, it's going to compress. It's going to make it flatter. Okay? So let's try number 4. Let's see who's going to do that. Noah. Noah. Okay, so Noah. So, what's your, what's your A value, Noah? 2. Good. What's your B value? 0. And what's your C value? Good. So I want you to find the axis of symmetry for me. Of symmetry, which is the negative B over, I'll give it to you, negative B over 2A. Okay? So what's my B? 0. So negative 0 over, what's 2 times 2? 4. And what's 0 divided by anything? 0. So where's my axis of symmetry going to be? At 0. Good job. Okay, so my axis of symmetry is going to be right down there. So my middle, my vertex is probably the same, you think? Probably, yeah? Okay, so let's try now. 0. So what other x values do you think we're going to use, Noah? The same ones that we used before or different ones? Think they're going to be, what's our middle? Is our middle the same? So probably the other points we could use the same x values, yeah? We're just going to get different outputs, okay? So let's use negative 1, negative 2, and 1 and 2, okay? All right, so now we're going to plug into y equals 2x squared. So how are 1/2 and 2 related to each other? What are they of one another? What's that word when we flip a fraction over? Reciprocal, right? They're the inverse of one another. Okay, so let's see what happens. So, Noah, what is negative, let's do 0 first. What's 0 squared? Times 2. 0 times 2 is 0. Good. Okay, what's 1 squared? Times 2. 2. What do you think negative 1 squared times 2 is going to be? Is it going to be negative? What's negative 1 times negative 1? Times 2. 2. It's always going to be positive, right? Okay. And then what's 2 squared? Good. Times 2. Good. What's negative 2 squared? Times 2. Good. Really good. Okay, so now graph that graph and see what happened. So we started in the middle. We started at the same place. Oh, Noah, what happened to our U? You got, what's that? If I take a rubber band and I go, whoop, or taffy, that's what I always think of with this word. You guys know what taffy is? Okay, what is that word that they do with it? They stretch it out, right? Good. So when that A value is bigger than 1, we call that stretch. Now think about that for a second. When we had a line that was like y equals 3x plus 2, was it a steeper line or a flatter line? Anybody remember? Think about that for a minute. If we graphed like y equals 3x plus 2, that was usually a steeper line, wasn't it? They all go together. They all work the same way. Okay? So one other question I want to ask you, and I'm going to take one of those. So, Gage, pick one of those two equations that we just graphed. Which one do you want? Number 2 or number 4? Number 4. Okay. So I want you to go down to the below, and it says, what do you think would happen if a is negative? So I'm going to take that same y equals 2x squared, but instead of having it 2x squared, I'm going to change it to negative 2x squared. So you ready, Gage? Okay. So we're going to put our 0 in the middle. So what numbers do you want me to use for my inputs, Gage? Perfect. Sounds good to me. Okay. Now, see there's that really cool poster up there that has the purple elephants on it? What does it say? What does that stand for? PEMDAS. Which part of this equation do we have to do first, always? The exponent. Please do not do it backwards. Please, pretty please, with sugar on it. Okay? You always have to do that exponent first. All right, Gage, you ready? You're going to start with a 0, or you're going to be brave and start with a negative 2? Oh, I like it. Okay, what is negative 2 squared times negative 2? Negative 8. What is negative 1 squared times negative 2? Good. What? That would be 0. Good. What's 1 squared? It would be 1. Good. Beautiful. Okay. Now I want you to kind of sketch those points. First of all, what do you think is going to happen? I want a prediction out of all of you. What do you think is going to happen to that graph? Reagan, what do you think is going to happen? It's going to do what? It's going to flip. Good. Okay, graph it to see what happens. So there's my 0, 0. Is my vertex still in the same place? Sure is. So I have negative 2, negative 8, negative 1, negative 2. Just sketch it. It's fine. 1, 2, and 2, negative 8. Looks exactly the same, still skinny, but it flipped over. Okay? So now, do I have a maximum or a minimum? Do I have a point that I can't get lower than, or a point that I can't get higher than? I can't get higher than this, right? Because no matter what number I put in, my vertex is as high as I can go. That's where the ball went up, and then it had to start coming down. It couldn't keep going higher because we're in gravity, so we can't keep going higher, right? If we're out in the atmosphere somewhere, maybe it would keep going up and up and up, but here on Earth, it's not going to do that, right? So now this is our max. That is a maximum. Okay? So when that a value is negative, what does it do to our graph? It flips it upside down. Good. All right, and I think that's what we're going to record for today.